Thank you. I'm very pleased to be invited to be participating in this conference and be able to share my work. I will specifically talk about the ability to take information from building information models and be able to enrich virtual city models. Obviously, there are other ways you can visualize BIM models and virtual city models in an integrated way, keeping the data separate. Or there have been other researchers before who tried to take building information models and convert them into in 3D city geospatial building models, but most of them, or all of them, have not really been useful in practice. So this is what I'll be talking about. And the context, the background for this is the development of a 3D city model, in this case virtual Singapore, being developed by the Singapore Land Authority and the Government Technology Agency. And the other motivation, of course, is the fact that we have building information models available. Even though actual submission in an IFC compatible form isn't yet obligatory in Singapore, we do collect more, or government agencies are collecting more and more BIM models, whether by in-house development, such as the Housing and Development Board or the JTC industrial developer, or for compliance checking, such as the Building Construction Authority and the Urban Redevelopment Authority. And so within this context, we had the opportunity to work on a research project funded by the National Research Foundation over a 2-year period, which just ended last April, on the strict and, well, that was the title, an automatic mapping of IFC BIM models into semantically enriched 3D CityGML building models. The whole point was to go beyond geometric conversion and also convert semantic information that can be found in the BIM models, and at the same time do this for both exterior and interior building structures. So the process, in a way, was to take a native BIM model, export it to IFC, convert it to CityGML, and then embed it into Virtual Singapore. And this is a project that we did together with with Ordnance Survey from the UK. So, as I said, going from native BIM to CityGML, and then actually, rather than Virtual Singapore, considering use cases, because that's actually the most important thing, rather than simply embedding this information in some data source that then we're not sure yet what we can do with it. But when it comes to the work structure, we obviously just couldn't follow that flow. And so we looked at the input models that we had available, acquired information from them, and at the same time looked at use cases that we could gather from collaborating agencies to define a target specification of what we wanted to achieve, and then filling in the blanks in the middle of going from the information that is available in the IFC to information that we want to have available, in this case, in a CityGML model. So the loop that we followed was we started from use cases. These use cases would then inform target specification in CityGML. That would lead to requirements imposed on the IFC, which in turn would impose requirements on the native BIM. And then we could, having established that, we could then take a BIM model that would fulfill those requirements, export it to IFC, convert it to CityGML, and then have it used within those use cases. And obviously, the emphasis in this project is on the conversion from IFC to CityGML, but we have to look at the whole together in order to be able to achieve this in a useful way. So starting from the first step, the use cases, we had quarterly meetings with a number of public government agencies in Singapore that all are interested in using the 3D city model for various use cases, some of them that are mentioned here, and trying to understand, do discovery sessions in order to get information about what they are interested in. Because obviously a BIM model has a lot of information in it. We could potentially transform everything to CityGML, but obviously that's not the goal or the purpose. BIM models are very large, and we want to make sure that the CityGML model is actually useful. Having established or having gotten this information, the next step was to have a target specification. Obviously, we're using CityGML. Part of the information that we're interested in fits perfectly within CityGML, but not all of the information can just be thrown into CityGML. And so we developed a ADE, an application domain extension, in order to allow information that is specific to IFC to be developed. And here's a simple, very simple example. Let's say in IFC we have information whether a room is handicap accessible. We would like that information to be available in CityGML, because that could be very interesting for certain use cases such as indoor navigation, wayfinding, etc. So, I mean, I don't want to go into too much detail, but an ADE allows the ability to extend the CityGML model. The CityGML model is an object model, so one way to do this is to add new attributes to existing objects. Another way is to add new objects to contain specific information that would be of interest. And thirdly, we also defined a number of property sets, code lists, sorry, which in our case are specific to Singapore, as that is the context in which we operated, but these could easily be amended to other situations. So for example, building types, these are the general building types, especially when it comes to residential, that you can find in Singapore. Then, in order to specify the IFC requirements, we need to be able to identify what information has to be available and in which format. So we adopted grammar rules, in particular triple graph grammar rules, on the basis that on the left-hand side we have an IFC model, which is a graph, which is represented as a graph. The CityGML model on the right-hand side is also represented as a graph, and the rules basically specify a third graph, which is a correlation graph, which identifies how objects in IFC can be linked to objects in CityGML, and how relationships in IFC could be reflected in relationships in CityGML. So it's a collection of three graphs: the IFC graph, the CityGML graph, and the correlation graph. And the rules are expressed in this triple graph. So it's quite straightforward to identify which objects and which relationships exactly are required in IFC in order to derive the necessary information in CityGML. So these rules both reflect on the conversion process as well as on the requirements, the search process to match these rules onto the information is reflecting on the requirements that the IFC has to have certain information available. The idea to use rules comes from the fact that sometimes that the conversion that we want to do should be informed from two sides. One is what information is available on the input side, what information is available in an IFC model. We can't just say, well, the IFC model should be a perfectly clean and fully developed IFC model. We should be able to work with IFC models that result from practice. And of course, on the other hand, we might not be interested in all information. We're only interested in information, for example, specified by the use case. So we could have a large set of rules reflecting on different kinds of input files and different use cases, and then from that large set of rules organized into different modules, we could then select a particular rule set that would provide us with the CityGML model for our specific use case. So we did that. We developed a large set of rules organized in different ways. And this is basically, from our point of view, the most important way we organize these rule sets according to spatial semantic characteristics. And basically, if you look at the top row, these are all rules that take triangulated faces, surfaces, a derived triangulated model, whereas all the bottom rules rely on native IFC geometries. The left part, so the left part, 1 through 4, are all rules that are focused on a three-dimensional model, whereas the right side rule sets are all focused on simply collecting 2D or 2.5D information in the form of floor plans. And then for each column, the first column is interested in objects, in 3D volumetric objects, and then the second row is interested in the boundary surfaces, and the same thing for the floor plan information. And so we could get a number of rules. I'm just showing you a few. So at the top we have an IFC space, which is translated into a building room. That space, of course, has to be part of a story, which can then connect to a story in CityGML, as well as a building that it would be part of, assuming that all that information would have already been made available in CityGML from other sets of rules. And then we also organize these rules into 3 layers. These actually correspond to 3 steps. The first step is that are rules that structures that occur in every rule set that are always required. Very general things that we always need to have present. The second are rules that are very specific to the target type of building elements, so whether it's 3D building elements or 2D building elements. And the third one are then rules that actually add the geometry to these spatial semantic units that have been defined in the second step. And we applied this to a number of examples, from a very simple to a real-world example. And so the rules are, in this case, there's about 20 rules identified into 3 layers. And for each model A, B, and C, it is identified how many times a rule is applied, so how many of those components were present in that particular building model. So once we have all that, we can then focus on the BIM export and the native BIM requirements. So there's 2 or 3 points actually that are important. One is that we use reduction and filtering using visibility settings. So what is not visible usually does not get exported to IFC. Obviously, we also work on the export settings to get exactly the information that we're interested in, but sometimes the requirements specify that rooms have to be available. Not all IFC models necessarily have all the rooms identified, so there might be some manual identification necessary in order to be able to generate the right information. And then, so we have the, so here at the bottom, the left-hand side is the native BIM model of that real-world building. The right-hand side is the IFC model, and then a conversion applies by selecting a rule set according to a specific use case, and then applying this. And here on the right-hand side is the CityGML model that has resulted from this conversion process. So where we, this was our onset, some abstract native BIM model going to IFC, CityGML, and to virtual Singapore. So we did this with our real-world building, converted it to IFC, and then to CityGML. But obviously, based on the use, on the rule set that we use, we could get a lot of different outputs. These could be 3D, they could be 2.5D, they could be focused on volumes of spaces, they could be focused on surfaces, etc. So there is actually the possibility to be based on different use cases. So what a user wants to be available for being able to do a particular task or a particular simulation, information could be selected and presented based on that. And then, obviously, we didn't leave it at this one building. We collected a number of buildings from our stakeholders, from the government agencies, and applied the conversion to all these models. And the process went, I must say, amazingly smoothly. It just showed that the rule-based approach was the right approach to allow for the kind of flexibility that is required, because these building models all came from different sources. They were not all developed by the same agency or the same consultancy, and but they were they all worked remarkably well. So then we get back to the use cases, and obviously this is just an excerpt of what might be possible. In the project we focus specifically on use cases relating to 3D rooms or spaces and 2.5D floor plans, and we considered different potential uses for these, and obviously these uses could be even enhanced by adding or linking it to additional data such as social data, maintenance history, etc. And here you can see, this again is for the example building that we focus most on it, but all this information, so the colors are different types of spaces, whether these are corridors or toilets or meeting rooms. All that information was extracted from the BIM model, and below is some information about the building itself. All that semantic information as well comes from the BIM model. And here you can see an example of a specific room, and it says whether it's carpeted and what the height is and what the room number is, etc. All this information was available from the BIM model. Now, to give you a little bit of background information, obviously we used standards. Specifically, we used IFC4 as the most recent IFC standard. It had quite a few benefits in terms of embedding coordinate systems, improved representation of space boundaries. But when it came to CityGML, we adopted CityGML 3.0, which is actually not yet a standard. It has not been released yet, but CityGML 2.0 is actually already quite old, and there's a lot of good ideas being embedded into CityGML 3.0, which makes it more compatible to some extent with IFC, and so we use that so that we could, we're running ahead in a way, but I mean this has been used also as an example in OGC with respect to the development of CityGML 3.0. So here's an example scenario of how this tool could be used. So let's assume that the use case is already known. Then obviously if it's already known, then the data specification will already be available. Rule sets will already have been created and available in a rule repository. So the actions then are to select the model from the IFC model repository, select the rule set from the rule repository, and run the conversion client. And the conversion client currently has, there's different ways one you can use it. We have a GUI interface developed as a Java tool, and there's actually also a command interface, so it can be just run from a command line if that would be useful. We also had to develop a viewer for CityGML 3.0 because obviously that was not available, so we customized the FCK viewer to allow us to visualize the CityGML 3.0 models. We also developed an interface inside of FME for those who are familiar with FME and like using it. So you can plug in, basically you can access the tool as one node in a FME workflow, and this makes it of course very easy to extract various views from the 3D CityGML that has been generated, and filter it and look at whatever might be of interest. Obviously in FME it does not support the ADE, but all the information can be embedded using just straightforward CityGML properties that can be added. The downside, of course, is that you don't know in advance what information will be available and how to access it. But this is just to show that the information that was available in BIM did make it into the CityGML model in FME. And I want to conclude my presentation here. I would just like to point out that end of September we'll be organizing the 3D GeoInfo conference in Singapore. You're all welcome to join us and attend. And there will be more information presented on this project as well as part of a GIS BIM workshop on the 25th of September. And otherwise, if you want more information, we have a website, ifc2citygml.github.io. Thank you.
Do you have any questions?
Thanks for the excellent and interesting presentation. The topic came to my mind with your workflow when you say you can derive different, say, submodels out of this BIM model. And Dr. Kometa in his presentation mentioned that the municipalities struggle or put a lot of effort in maintaining the models. Which model do you recommend to maintain? The CityGML model then, or the IFC model?
Originally we developed this for virtual Singapore. And there's an assumption that there's a certain amount of information that would be relevant for virtual Singapore. But we didn't actually have access to it. So that's why we reached out and figured that obviously different parties for different tasks are interested in different parts of the information. So the idea is that what we would like to do is that you can actually add an authoring tool to this, where you can actually specify, well, this is the information I'm interested in. What kind of, how can I get this information out? How can I get this into CityGML in a format that I can use? Obviously, it doesn't necessarily even have to be CityGML. It could also be other graph-based models, indoor GML, etc. These are things we've considered, but obviously didn't have the opportunity to develop this. But when it comes to maintenance, obviously the problem is that all the BIM models that we've been working with are all as design models. In fact, even then, they are not necessarily the final design. Sometimes the information that they put in for material information of the building, might just be kind of like defaults that are very close to what they will use eventually, but not the actual. Because unfortunately, this is a problem, of course, of the BIM world, is that there's a lot of uses for BIM, but it is not necessarily pulled through all the way from conception to construction. And so, in that way, it's a bit of a chicken and egg situation. I mean, hopefully, if they see the use of taking this BIM information and having it available in a 3D, in a virtual city model, that there might be initiatives to enforce that we get as designed, as built building models, or etc. So adding maintenance information is, yeah, I mean, some of these use cases are a bit theoretical, I have to admit, but it is also because the first time when we asked the government agencies, what do you want to do with this model, this CityGML model that is virtual Singapore, they couldn't answer us. So throughout the discussions that we had and the regular meetings that we had to actually push them to start thinking about potential uses. And so in that sense, there was no specific outcome where somebody used one of these models and went on. It's really, to that extent, it remains a demonstration. Fortunately, the demonstration is not about whether it's possible to go from BIM to CityGML. The demonstration is, you can get a CityGML model, now what do I do with it?
Another question? Okay, thank you.
Also from my side, a real great presentation, a hot topic, because the kind of modeling is so different in both, even if it's from the ideal side. How do you deal with different types of modeling IFC or BIM? So when we get some models from our clients, once it's clear that they are not really identical from the kind of modeling. So this is a huge challenge for what we try to do, and I think we of course will have a look into your research results, because using FME and ADE, that would be amazing. So, but the question again, how do you deal with different kinds of modeling alternatives?
Yeah. So, I mean, admittedly, so we did want to ensure that we could use a large variety of models from different sources that are used within Singapore. Now, obviously, we've come across some models that are just not worth calling an IFC model in the or a BIM model in the sense that there's nothing you can do with it. It's a BIM model by name. It was a requirement, and somebody spent a few days on creating it, but it is so bad that there's nothing you can do with it. What we did, so we identified some minimal requirements. And so these spaces, for example, is one of the minimal requirements. If those are not available in BIM, then it becomes very difficult. There are a few more. This information we all provided to the Building and Construction Authority, who are eventually this is where BIM submission occurs, or should occur once it is required, and they are developing a platform 2.0, because they already had a platform very many years ago, for electronic submission that hopefully will embed these criteria so that people know what to adhere to. And so we've also been thinking, well, shouldn't we then give these developers of these BIM models the tools to actually check themselves in advance before they submit it and then get back? No, it's not. But I must say, it's not an incredibly long list. It is not nitpicking about details. It is some fundamental issues that just have to be available. And for the rest, now obviously we haven't converted every little object in BIM. So there might still be, there's still a gray area, but we definitely converted 90% of all the information, and with those few requirements, the process works remarkably well.
Great.